Okay, it is 10 past the hour. So everyone, this is Sander's session with hacking and hacking mitigation for SQL Server. Take it away, Sander.
Okay, well, thank you, everybody. Welcome to my session, with all about hacking and how we can mitigate all the hacking vulnerabilities in our systems. So for the next 60 minutes or so, we're going to talk about why this is so important, how hackers gain access, how they think. If we know how they think, we can probably counteract that. And of course, I'm going to show you some demos. Like I said before, I did record my demos, so don't put some negative feedback on that. But I usually break my demos every single time I do this. So just in case that I don't have to rebuild everything, I have the recordings. And I'm going to do some Q&A. Some presentation rules before we start. I want you to always ask questions. Please interrupt me whenever you can. So if you have a question, just ask them right away. And this is a two-way conversation. So I want to learn as much from you as you want to learn from me. A little disclaimer. Any of the content you'll see today is only for educational purposes. So if you do any nefarious things with it, you're on your own. So these kind of things are well documented on the internet, but I don't want to be responsible for you doing any dumb stuff because you will get in trouble. So I'm Sander. I'm a data platform engineer working at Data Masterminds. I have over 20 years experience in IT. I've worked in a variety of industries from agriculture to healthcare to financial industries. And I've seen a lot of environments and a lot of things go wrong with security as well. I have a blog if you want to take a look at that. I try to blog as much as I can, but time doesn't permit that all the time. If you have any questions after this session, feel free to send me an email. I'll try to reply as fast as I can. I have a Git repo with lots of different content in there, so take a look there if you want to. Most of it is just public. And if you want to follow me on Twitter, that's my Twitter handle there. So why is this so important? Well, the question is not why is it important, why it's a matter of when you're going to be attacked, not if you're going to be attacked. We really underestimate all the different things that can go wrong in security. And normally when we secure all our entire environment, it's a hassle, right? You have to get permissions and do all the things correctly, but in the end, it helps you a lot. So normally we're against all the strict permissions, but I'll show you later on why we actually do this kind of thing. So how does a hacker gain access? So first of all, we've all seen the phishing emails that really look like the original sender, right? Where they even do things with the logos and the complete same text, but just have a link. Don't click on these kind of things. Make sure you educate people in your company to make sure that people don't click on those kind of links. USB key malware. Don't put any USB keys in your workstations that you're not familiar with, right? There could be anything in there. I have a couple of these laying around. If I put that USB stick in your laptop, everything is mine on there, and you wouldn't even know it. Scanning networks for vulnerabilities. We have a variety of tools to go in there. We can use Nmap, for instance, to scan for open ports or vulnerabilities. We can guess passwords or socially engineer them. We can call up like I lost my password or anything like that, and then act like somebody else. Wi-Fi compromises. One thing I never ever do is connect to a hotel Wi-Fi ever. Don't do it. It's way too easy to compromise such a network. I can put up a rogue access point within a couple minutes, and it only costs me like $40 once. So if I can do it, anybody can. Credentials from third-party website. Maybe you have a third party that gets hacked and all your passwords are there. So we can get through to your company through third parties as well. Compromising web-based databases. You might think that SQL injection is no longer a thing, but it's still very active and still, due to bad coding practices, it's still a thing since the 1980s, something like that. And insider attacks. So people from the inside are a big threat. So they probably know about your network. They know all the servers, maybe even some credentials. So you need to be aware of that as well. So how do the hackers think? So there was a study by Tycotic, what the motivation is for hackers to actually get into a system, get into a network or into a system. And 51% of that is a thrill, like, oh, nice, I got in. And it's mostly the challenge to get in. 29% is moral compass. That's the white hat or the gray hat hackers that want to prove a point, like, hey, your system is not secure. 19% is money, which is you've all seen the news items in the news about ransomware attacks or hacks in companies that they ask a ransom for. And only 1% is notoriety. You don't. Only the dumb hackers actually want to get notoriety, because the harder you scream, the easier you're gonna be found. So not a lot of them do that. So what does it mean? So you either choose to be one or you are one. So if you've been tinkering with little devices when we were younger and make them do things that they weren't supposed to, you're probably a hacker. Or you're very interested in the techniques and you actually start doing it later on. They experiment with systems to the limits, and they have a real compulsion to experiment with them. So to get them to the limits, to let them do things that they're not supposed to. So they understand the most fundamental piece that we work with all day long. Like all the stuff, all the technology that we use is based on code. So if you understand code, you can probably tinker with a lot of, if you can talk with applications and let them do other things that they're supposed to. They want to control and command all the systems, and they learn very fast. So they learn during an attack, like, okay, I need to do, this is not working, let's try something else. And they learn very fast how to get into systems. So let's go into some demos, because that is the most interesting part. So the first thing we're going to do is something with SQL injection. And we all seen this cartoon Bobby Tables, that he did something and suddenly all the entire database is corrupted. What I'm going to show you is using an application called DVWA, definitely vulnerable web application. It's freely available on GitHub. It works. This one works with a MySQL database, but it could be any database on the back end. The techniques are still going to be the same. So let's play this little thing, and I'm going to talk you through it, what's going to happen. So we have a simple web form, and in this application you have different ways you can do vulnerabilities with web application. That's to show you what you can do. So we put in a number, we get a result. Very easy way to do this. 2, gonna get another result, and we can go on and on and on. What's going to happen next is we're going to try to figure out if that field is vulnerable for a SQL injection attack. So what normally happens with SQL injection is that you have a concatenation of text, and because you put in a certain value into a field, then suddenly it works differently with a query. So what we put in here, let me pause this for a second, is a percentage sign. So if we have a select star from users table, and suddenly where ID is, and then a single quote. And if you put the rest of the code that I put in the field right here next to it, it's going to say, okay, get me everything. and or 1 is 1, which is always true. And then it's going to end the query. So if I submit that and it's vulnerable to SQL injection, I should get something that the system is not supposed to do. That is basically what SQL injection is. This is the easiest example. We can do even more. So if we do stuff with the next part, what we're going to do is we're going to select some, I'm going to say 0, 0. And then we're going to get the user that's actually connected. And that is the DVWA at localhost. You're not supposed to know this information, right? So that's only supposed to be on the web server. We can do the same thing for the database. So instead of getting the user function, we can put in the database function as well. So we're going to replace the user and just put in database. This could be any kind of function for SQL Server as well. And there we've got the DVWA database. So the next thing we can do, we can even explore this further along. So then what we can do is we go in, and now we're going to get, if I'm right, we're going to get the tables, so the table name, from the information schema tables. Ooh, keep on going. And there we are. So now we have all the tables. We shouldn't be able to get that information. So if so this is probably not going to be very effective. So we might want to look for low-hanging fruit. So what the next thing I'm going to do is I'm going to select anything that is start with user, something like that. Come on. Yep, we're going to put in a where clause. Where, there we go. Your table name is like user. Even in demos, I don't type very fast. There we go. So there are two tables, user and users. Well, users, the singular one is probably not going to be interesting. So let's figure out if we can do anything with the users table. So we're going to use the same kind of query that we did before. Again, we're going to select everything, so that way we get all the information. Going to put in another piece of code, and then do a union all, or a union, and then select not the first one, and do a concat. And with the concat, we can actually get the in this case, we're going to get the table name, and then we're going to put in an extra character just to make sure we can get all the information, the column names from the information schema columns. Where the table name is, of course, the users. So that way we can figure out if there are any columns that we want to investigate. So we have a couple columns that are probably interesting. We've got a password column and a user column, first name and last name. So the next thing we want to do is going to select the information from that table and get the password and get the username. Maybe that is a weak password, and then we can do something else with it. So again, put in some code. And the funny thing is, this is manually done. I'm going to show you later on how this can be automated. So we're going to get the first name and the last name, and we're going to get the user and the password. Go. Password. And end it. Yep. Okay, there we go. So I'm just going to pause this for a second. This is, if you know a little bit about hashes, this is a typical MD5 hash. So I can go in and crack this password within a couple seconds, because there are even websites later on showing one of the websites that's able to do that. So I know for a fact that this is going to be a weak password. So I can try out, I can probably copy that text and then go to a website like crackstation.net and get to it and then hack that password. It's that scary, because if you still use MD5 hashes, everybody should know that this is way too weak nowadays. You should salt your passwords and hash them a couple times. So you really don't want to use that technique. But in this case, it's a vulnerable web application, right? This is the entire goal of this application. The next thing we want to do is something called called blind SQL injection. So there are actually two types of SQL injection. There are standard SQL injection, which you just saw, where you just put in values into a field, and you can automate this as well with scripts. But there's also blind SQL injection. And with blind SQL injection, you have two types. You have Boolean based and you have time based. And what happens with blind SQL injection is that we put in all kinds of values and we try to figure out what the right value, with yes or no questions, what the right value is. And then with Boolean, we only get what is the correct SQL query. So we only get results from that. And with with type-based SQL injection, we actually look at how long it takes for something to respond and act according based on that. So with blind SQL injection, we can use, we're not going to do that manually. So we're going to use something called SQL map later on. But first, we need to get some info. So we're going to use Burp Suite to visit that URL, because we need some settings like the cookie. We need a session ID for the PHP session. So what I'm doing is I'm going to open a browser to that URL, and I'm going to find out that PHP session ID. Normally you go to the forum and then get a post, but you would get other, we only need a session ID for this demo. So the next thing is we're going to go back. By the way, I use Tmux as a terminal, which is a really good terminal for Linux. So we're going to use not QL map, but SQL map. And in this case, it already knew what I was going to do. So we're going to use most of that. Yep. Remove the rest. And we're going to put in that session ID. So I'm going to go back to Burp Suite, get that session ID, copy it in. There we go. Copy that. And I want to emphasize these methods are well talked about on the internet. So this is not something new. So this is our cookie that we want to use. And we're going to put in some data, because otherwise it's not going to submit anything. So we're going to put in an ID. It doesn't really matter which ID we put in, as long as we put in the ID, because we know the ID field, which is in the form, is actually vulnerable to SQL injection. Okay, so the -p is going to indicate which field in the database we're going to use. And then we're going to look up all the databases. And these are all the databases that are on the system. So in this case, we used it tried a Boolean based, which didn't work, and then it did an error based. But this with the time based, it actually got through to the MySQL server. Again, this could be any database system in the backend because this all works the same. So let's clear the screen. And we're going to do the same thing, but then we are going to get the tables. It takes a little while. Ooh. No, that's not it.
Sander, do you have time for a couple of questions while you work on that, or do you need to wait a minute?
No, sure, go ahead.
Okay. One, so from the very beginning, when you first were introing your topic, what is the alternate to public Wi-Fi? I get calls all the time and I have to pull over and sign into work.
Well, I may need to emphasize that. Don't connect to a public Wi-Fi without a trusted VPN connection. So make sure everything is encrypted, because if you connect to that public Wi-Fi without a VPN, then everything is going to be clear text. And you have basically a man-in-the-middle attack. So what happens, and I've actually tested this at home. I made a Wi-Fi access. I made a rogue access point. I made it open for everybody, and it had a name like a very fast internet connection, something like that. Free internet, and people connected to it, and I could literally it would decrypt all the passwords and everything on the fly for me for when they were connected to it. It's so if you use a VPN, it's going to be encrypted, and then actually you solve that. But don't connect to any public Wi-Fi without a VPN connection.
Okay. Next question. How much of this more in-depth hacking for SQL is done by a team of people who really like to code/hack, as opposed to people who are more script kiddies, DDIES, not like cats, and using some pre-packaged tool?
So most of the stuff that I show you is used by script kiddies as well. So they use articles on the internet and try to get in. There's only there's a lot smaller group that actually want to that develop the tools that you will see later on to use to do the penetration testing and to get into systems. So unfortunately, nowadays you can very easily buy go on the black market and buy an already developed tool for only a couple $100, something like that. So yeah, there's a pretty big group that uses that, unfortunately.
Okay. Last question that I have for you for now. What about SQL always encrypt? Would encrypting PII, etc., work against hacking?
So encrypting your personal identifiable information, probably, yeah, it would make it a lot harder. Unless they get into your system in other ways. So as soon as you're in the database server, you can do the Slack queries as well. So that only works on data that is in transition. So as soon as you get it, as soon as you get into the database server, you have the data anyway.
Okay, I will let you get back on topic. That was the last one. Thank you, sir.
Okay. Sorry, Sander, just one note to all attendees. We're having an issue with our Q&A in the Zoom, so please use either the Slack channel or the chat. Thank you.
Okay, cool. So let's continue this video. So this time I am using a few different parameters. So I'm still going to use the ID field. And this time I'm going to go into the DVWA database because we found out that's the database we actually want to see. And we're gonna get all the tables, and we're gonna do this in a batch way. Maybe there are a lot of tables, so we don't want to do this in one go. Maybe that's too much data. So apparently this database only has 2 tables, guest book and users. This is only an example database, but it could be a lot more. So the next thing we want to do is go in and dump that out. So this is one way to get all the data in here. And I'm going to pause this for a second. It exported the data automatically to somewhere locally using the for SQL map to my home. And it already knew that, okay, this is probably an MD5 hash. Let me try to decrypt it for you. And it already see that that is done. So we already see the passwords, and they're displayed right here as well. So for the admin, the password is password. Really good. Fine. But this is how easy it is. So if you don't have proper hashing in the table of your passwords or anything like that, anybody can do this as soon as you get in. There's another way that we can do this, so we don't have to. I'm first going to show you how to what it looks like for the CSV. So it actually exports it entirely for me. Paste a selection. Of course, that's not going to work because there's 2 rows. There we go. There we are. It's just a simple CSV with the passwords and everything. So from there, I can collect that and then use that to my to another machine outside the network, and then try to get in through another way as well. So the last thing I want to show about the SQL injection is we can also directly go and don't even look for a certain database, but we can go in and search for a specific table and then let it export. So so the difference here is that we have a data. I'm going to remove the database. No, go on. And I'm only going to use. I'm only going to look for the users table. So it's going to iterate through all the databases and dump it out, same kind of way that we did before. So if you just want to use go for a users table, it's going to find it and export it for you, the same way it did before. So that is that part. So how can we prevent anybody using SQL injection? So first of all, parameterize your queries. Don't use the concatenation. Just don't make sure that you put that in parameters, and that's easier to follow. Also, your web application should do input validation. Your user should not be able to put in any values that are not allowed, like the stuff that I put in, like the entire query stuff, should not be able to get in there. Make sure that you have the correct parameters. So make sure that they have the correct type, the correct length, the format, and the range. You don't need a 255 varchar field if you only expect like 20 characters. That's gonna that is not necessary and actually is vulnerable for attacks in this way. Use store procedures so that your parameters are in the store procedure and you can put everything nicely away, and also that for performance reasons, but that is out of this session, but you can use store procedures to increase your performance as well. Use character escaping functions. So since SQL Server 2016, we have the string escape. So if there's any special characters in there, it's going to escape them. So I cannot put the single quote in there without being escaped, and that would generate a query error if I wanted to do SQL injection. So that prevents me from doing that. Also, your application should do character escaping as well before it sends it to the database. But it's also good to put that on the database end as well. very obvious, set the correct privileges, make sure that that user is not able to select all those other tables if it's not supposed to. And we have something called a WA, web application firewall, that's able to monitor and filter any of these HTTP attacks. So you can also put that in place if it's a really busy system, for instance. And the reason we want to do that is we want to one of the things that hackers do is they try to move around your network in a silent way. So as soon as somebody is on your system, they will listen to the error. They will listen to what's going on. It could be weeks or months before they take any action, but then they try to get into other systems. And as soon as there's like a critical point, they will try to attack the entire system. And it's probably going to be in the middle of the night. I've had that at a previous employer. We found that they had hacked us months before, and suddenly on a Monday morning, 1 a.m., our entire infrastructure was encrypted with ransomware. So you want to prevent them going to other servers easily. And there are things like honeypots that you can put in place. Make as many hurdles as you can to make sure they cannot move around your network. That is what we want to prevent. So the next demo we're going to see is using Metasploit. And Metasploit is a penetration testing framework that makes hacking very simple. It's a tool for developing and executing exploit code against a target machine. And then the Metasploit project is hugely popular for pen testing and the hacking community. So it's essentially a computer security project that supplies you with information about a system, but it also helps you to formulate your penetration testing and IDS testing, and also how the strategies are set up, and even the methodology. So you can even document how you got in. So in this case, we're gonna here we go and play. This is really annoying. So first of all, we're going to use Nmap. We want to find out if there are any SQL servers in our network. In this case, we're going to use -sv, which is a TCP. Let's Nmap know we want to do anything with TCP. We can also do UDP if we wanted to, and then it will be SU. So, and we're going to scan all the addresses between 10 and 50 on port 1433. This is going to take a couple seconds. And it's probably going to come back with 3 hosts and only one that has port 1433 open. There we are. So it gives us some basic information, the IP address, of course, and then the Microsoft SQL Server 2019. We already found that, and it has 1433 open. This is just one tool. We can also use Metasploit, which we start by typing msf console. And now we're in the Metasploit framework. And we can use something called MS-SQL ping. And MS-SQL ping enables us to essentially do the same thing. So we're going to use a scanner, MS-SQL ping. Let's change that. And then we have to set a couple options. So we're going to set the remote hosts. Well, in this case, we only have one, but you can put in multiple if you wanted to. We're going to set the threads, so we don't want to generate too many threads. And then we're going to do run. And this gives us some basic information about the database server. It's not clustered, which version it is, it has named pipes enabled, and that already gives us some information how we could probably get in. Maybe there's an exploit on that specific version of SQL Server. we can also do the same thing. We don't have to do it on a single one. So we can do this based on a subnet. So maybe we want to do the entire subnet and then do the same run. And then we can scan everything. The thing is, if you do these kind of things and you try to get into a system, you will probably be found, because that is something that comes up in monitoring, should come up in monitoring. So we found the same kind of thing. I just stopped it because otherwise it's going to go through all the 255 hosts. So we found the server. Maybe we can use something like password lists to log in, right? So maybe we already saw it wasn't a strong password. So we can use something called the MS SQL login. And we can set it to a certain username or a user file. And nowadays, all the passwords and usernames are online, so we can download these lists and generate and use them if we wanted to. So in this case, I'm going to set the user file, and the next thing I'm going to set is the pass file. So I may have already known passwords, and it's basically going to iterate through it. So passwords txt. I'm going to set the remote hosts again, because that is which one we're going to attack. So if you're not monitoring on failed logins, we're probably not going to find out that there are a lot of failed logins. I'm going to set the verbose to false, otherwise I'm going to see a lot of failed logins. I'm going to set the amount of threads because we don't want to be too noisy. And then we're going to do run. And apparently admin has a really weak password. This is this could take a lot longer, but in this case I didn't have a long list, but otherwise it could take 3 minutes or even hours. And the next thing I'm going to do is I'm going to exploit. I'm actually going to use an MS SQL payload, and I want to try to get a connection to that database server without actually getting a connection. And that's what we call a reverse TCP. And what this is going to create is a interpreter session. So I'm going to set the L host. This is my local hosts. And I'm going to use port 443, which is not going to be noticed, right? It's going to be port 443 that's been trusted. And then I'm going to set the remote host. And then I'm going to set the username, because we found that in the previous section. I'm going to set the username and the password. Actually type this correctly in one go and do a run. And now it's going to execute a payload to that server, and we're going to see if we can get a connection. Something that shouldn't happen, right? And it's using all kinds of tools and all kinds of stuff in the background to do these payload deliveries to get there. So sending it, yes. So we have a interpreter session, and now I'm going to do sysinfo, which is a normal command in Windows, and I actually have information about this server. This is getting to a point where, okay, this is going to be a problem, right? So if we get to this point, and this is just one factor how we can get in, but there are many ways to get in. So somebody who wants to get into your system and gets to this point, you're probably going to end up with a compromised system.
Okay, so I'm going to jump in again, Sander, really quick.
Go
just
ahead.
A few questions before you move on too much.
Yeah.
How effective is SSL encryption?
In what regard?
I don't know. That's the question. You get to decide. Dealer's call.
So SSL encryption only encrypts your connection to between 2 points. So I'm not sure what that would make it any better. If I can connect to your system.
So the answer is meh. It's okay. It's not all you want to use. You better use other stuff, right?
Yeah. SSL is not gonna. SSL is not going to be the only thing you want to do. Later on, I'm actually going to tell you what you can do about these things to make sure that you mitigate.
So, and then comment, then a question. I always argue that input validation is not needed when you correctly parameterize all queries. And if that is insufficient when you don't. In other words, why do you suggest input validation?
So the more hurdles you put in to secure your application, the better. If you don't want people to put in any number or any text, then or it should only be numbers. Why should they be able to put in any text? It just makes it more complicated to do these kind of attacks, to do SQL injection attacks, and it just makes your application more secure and better documented. So in the end, you don't end up with weird results in your database as well. So I think you should always put in input validation in your web application and in your store procedures. Try to expect what you make sure that what you expect is actually being sent.
Okay, you're good to move on. That was all I had for right now. Thank you.
Cool. So the next part I'm going to show you is going to be about a feature you may be using, which is a trustworthy database. So this is not the correct slide. So we got some credentials. So maybe I'm using SSMS in this case, but I could use any kind of connection tool to get into SQL Server. But in this case, I'm using SSMS because it's more GUI and better to show what's actually going to happen. So I'm going to connect to that database. I already know the password because I got that extracted. And I'm going to connect. And I'm going to look at the databases. This is just a simple sample database with not many tables in it. They didn't need any tables. And we're going to look at the security. So there are a couple users. We're going to, of course, admin, because we got in. SA is enabled, apparently, and we got 2 other users. So let's take a look at user 1. User 1 is a SQL user, doesn't have any server roles, but does have a public role. It doesn't really have any permissions on the trustworthy database, but it does have a user. So look, the database owner is SA. That's what we always put in, right? That is what we want. And then we go to the options, and you may have guessed in the options, the trustworthy option, the trustworthy configuration option is on. Okay, that is actually a problem because we can escalate this and then have a user who's not a sysadmin become a sysadmin. So let's check this again. He has no server roles in here. Let's go back to our Kali Linux instance. There we go down, yes. Apparently I was confused doing this demo. So let's go in and use another feature in Metasploit. So we're going to use something called the MS Escalate DB owner. This is in the auxiliary admin MS SQL and then MS SQL Escalate DB owner. Yep, DB owner. We're going to set the R host, again, remote host, to be 10, 13, 37, 31. And then we're going to set the username. And we found, just imagine that we found the same kind of password for the user 1 because we can already get in. And maybe it's the same weak password. So let me pause that for a second. So what this did within a fraction of a second is it checked if the user had the sysadmin role. Nope, not the case. So let's see if we have a trusted database owned by sysadmins. That was actually the case. So that database was owned by SA. SA was enabled. We didn't have the SA password, so we didn't put it in. What affected databases was found on the Safe Trustworthy DB, checking if the user has the DB owner role in any of them. Yes, that's the case. And now you're a sysadmin. Congratulations. So let's check if that's actually the case, right? Let's go back to SSMS. So let's go and look at the user. And of course, it's going to be a sysadmin. That was the sysadmin. The user wasn't the sysadmin. I just escalated it to be a sysadmin. And this is how dangerous trustworthy databases are. Because if I can get in and I put these scripts in, I can become a sysadmin if that owner is not set correctly. So one way you can mitigate this is by disabling the SA account or renaming it, and making another SA that's actually your new SA account to use. So that was this. So do we have any questions before I show you the last thing?
Checking really quickly. There are many. There's a lot of snarky crosstalk. Big surprise.
Snarky crosstalk.
No, snarky crosstalk. Yeah, that's the name of my college garage band. No, I think you're good for right now. Go ahead. We'll
Okay, cool.
We'll wrap anything else up at the end.
Cool. Let me get a sip of water.
Oh, while I'm unmuted, you have 13 minutes, sir.
Yeah. I'm gonna make that.
Okay. Cool.
So the last thing I want to show you is a golden ticket, and a golden ticket is a Kerberos ticket granting ticket that is manually created by an attacker that can grant any ticket to any service on the network. And to explain what that is, in short, it's the KRB TGT is the Kerberos Distribution Center service account used in a Windows domain to handle all Kerberos tickets, ticket requests. So that account password is used to encrypt and sign all the Kerberos tickets issued by the KDC. And with that, the account password is only known by the Kerberos service and the domain admins. So what we can do, and in this case, we have one thing we want to prevent is that normal users get into the domain controller system drive, because as soon as we get in, we can probably get the Active Directory database, pull that out, and then offline use other tools to decrypt that, because we can get all kinds of resources nowadays in the cloud, spin up virtual machines, and then use that to decrypt things. So what we want to do here, so I'm going to show you that this user 1, has no access to this domain controller. What we're going to do is we're going to use Mimikatz. And Mimikatz is one application that can be used to create this golden ticket. I can do this in Metasploit as well, but I wanted to show this in a virtual way. But I can just put this in memory only, so it doesn't have to be an application. So just go a little back. So what I did here is I used the DC sync function in Mimikatz to dump everything out. And one thing I want to use is the SID and the NTLM hash. So what I'm next going to do is going to create a golden ticket with this, with the credentials that I had. So I'm going to use the user administrator, could be any user. I'm going to use the domain, mlab.io. This is actually my domain that I'm in. I'm going to get the SID. And then I am going to put in the hash for the Kerberos TGT. So I'm going to go up, select that. And at last, I want to put in the ID, which is 500, which is the administrator, and the groups 512, which is the domain admin. This is, by the way, default. I want to put in the renew max, which is 10,080 minutes, which is 7 days. A golden ticket. I want to save that ticket locally for reuse. And then I'm going to clear the screen. I'm going to list all the Kerberos tickets that I have so I can show you there are no smoke and mirrors. I'm going to load that Kerberos ticket using the PTT, pass the ticket. That's what it's actually saying. And now it's loaded. I'm going to, it has the administrator.io, a normal expiration date, and it's using that domain. So the next thing I want to do is, of course, I typed this wrong in my demo, but it should be miscellaneous, not msic. So it's going to be miscellaneous, and then I'm going to use another command and that pass the ticket that I had. So at this point, I'm going to do the same stuff that I did in the other command prompt. I'm going to copy the dir command because I'm just lazy and I just don't want to type. And now I have access to that domain controller. From this point on, you're in trouble because I can get that data. I can get all kinds of information from the domain controller. I can get the database, pull that out, and then decrypt that somewhere offline, and then not even make any noise on the network from that point on. So this is how easy it is. I can do this through Metasploit as well. And then it's called load kiwis, same kind of command, same kind of way to do it. I don't even have to change tools, but this is just one way I can do it. So how do we prevent this? So one thing you want to do is change your Kerberos TGT password regularly. So Stake is one of the centers that has a lot of standards. Says it to change it at least 180 days, but Microsoft says do it regularly. But I wouldn't do that too many times because you have to be aware that changing the Kerberos TGT password will affect almost all Kerberos operations. So any tickets that have been issued are going to be invalid. So don't do this too regularly because all the it's going to wreak havoc in your network as well. Minimize the account number of accounts that they can access that hash. So if you of course don't give users admin authority on their workstations, and don't let admins log on to end user working computers, because if there's a session, we can steal that session, get that hash, and then get going again. Monitor your environment. So one of the things you want to do is to check for long TGT lifetimes. So by default, if you create a golden ticket, the lifetime is 10 years, which shouldn't make sense. Normally, a ticket is like 7 days. Don't gain controller activity. If there's a lot of application replication going on, or if there are any executables on your domain controller, like PowerShell scripts or VB scripts, then you really want to monitor for that. Any changes in privileges. especially the stuff that I did with debug privilege, the privilege debug that you saw, that is shown somewhere. So if it's suddenly enabled, you should investigate immediately. But you need the right tools for that. One thing we have within Data Masterminds is we don't use legacy antivirus. We use something called CrowdStrike, but there are other applications as well, like Sentinel-1, and they do really sophisticated memory scanning as well. So where legacy antivirus scans for files, you should really look into other tools like that use something like they actually use AI to learn how the viruses or how the attacks spread. So pointers to remember: security is a mindset, right? You need to make sure that you have the correct mindset and make the right choices from the beginning. Hackers think differently. They're not admins. They will try to break everything and make sure and to get in. People are always the weakest link, and think about your choices, how to develop or to set things up with security in mind. I know it's a hassle to if you have a lot of security, but you don't want to be that company that says, oh, we just had all our data on the internet. At last, one thing I always what I like to do is use TryHackMe. TryHackMe is a website that lets you spin up labs and then have something like some sort of capture the flag kind of construction where they give you little assignments and you learn how to get into systems or even protect them as well. So this is a good learning resource if you are interested in it. CIS is the Center for Internet Security, has a lot of standards, how to do things, how to set things up. STIG is for the same kind of thing, even more thorough for the USA military. And OWASP is a good resource for any vulnerabilities that are out there. So, and with that, I think I only have a couple minutes left. So if there are any questions.
Okay, definitely have. Let's see. So just a minute, just a few minutes ago in your demo, the 502 at the end of the SID, why did you exclude it from copying and pasting?
I don't need it. It figures it out. Okay. It's almost always 502.
Okay. And why would changing the SA account name prevent this kind of attack? The database would still have a sysadmin as the owner with just a different name. But if you're already in the database, couldn't you see the name?
So you keep it as A, but you disable the SA account so it can't log in. So you keep the database owner at SA, you disable the SA account, and you use another account as SA with a completely different name.
And I have a request to copy and paste the resource links in the chat, but Anthony, I'm pretty sure you have a GitHub repository where you're going to put all this stuff. Is that correct?
That's correct.
Oh, Rob just put in the chat that he's going to ask Sander to do so, like he has to do my job. But Anthony has a solution. Someone asks, does the golden ticket only appear in AD environments?
Yeah, it's a typical AD attack. So it's Kerberos.
Okay, and then last question that got asked pretty early on. I just wanted to hold it to the end. And you have about 90 seconds. Is there a VPN that you recommend for people?
Most of them are good, but I know that Proton has a good VPN. I use Mulvad, which has quite a lot of countries as well. There are a bunch of them are good, but I know Proton and Mulvad. I particularly use Mulvad, MULLVAD, in that case. But yeah, make sure that you have a VPN connection when you are on public Wi-Fi all the time. And otherwise, don't connect to a Wi-Fi connection.
Okay, and then that was it. I think let me check YouTube really quickly. Let's see, how does zero trust change things around related to the threats just covered? And this will be the last one.
How does zero trust? So if you don't
It's-
trust anything coming in, then there's no way to get in, right? So if you make sure that, so normally you have two approaches. You open everything and you close all the ports accordingly, or you have everything closed and you open everything if you need it. And that's probably the latter is the one that the person is talking about. So you don't trust anything until you actually need it. That really helps because you won't have any open ports that are not you are not aware of, and you should document everything very well to make sure that everybody knows what's open and what's not.
Awesome. And we are at time. So
Cool.
I will
Good
pitch it
timing.
back over, I guess, probably to Rob. I'm going to send you a question in the chat that I'd like you to answer, please, sir. And I'll answer it on YouTube since we're done here.
I'll stop sharing my screen then.